So we're going to look at solving a system of equations slightly differently today. We're going to look at solving them algebraically. And what algebraically means is using mathematical or algebraic methods in order to solve the equation. We won't be looking at the graph. Essentially, we'll be doing this by hand. So the easiest way to do this is by a method called substitution. And substitution requires us to isolate one of the variables in either equation. Ideally, we're going to isolate y. It's just going to make the math easier later on. As we can see in the first equation, y is actually relatively easy to isolate, so I'm going to go do that. It's going to take me 2 steps, but if I take y to the other side, and then I subtract 10, I'll have y isolated. Now, what this equation actually means is that 5x minus 10 equals y, literally translated. Equals in English means is, so 5x minus 10 is y, or vice versa, y is 5x minus 10. What that means is that any time I see a y in the other equation, I can replace that y with 5x minus 10, and it is exactly the same thing. So I'll then go to equation 2, and any time I see a y, which is only once, I can replace that y with 5x minus 10. Why am I doing this? Well, that equation, the way it was given, had 2 variables, x and y. And it's impossible to solve one equation when it contains 2 variables. So we need to find a way to get that down to 1 variable, and that's where the other equation comes in. We were able to define y in terms of x's. Y was 5x minus 10. So we were able to replace that y with x's, and now we have an equation with just x's. A little bit of work to do to this equation, though. We need to distribute that 2 into the bracket. So we'll have x squared plus x minus 10x plus 20 equals 0. We can combine a couple of like terms. We've got x squared minus 9x plus 20 equals 0. At this point, and as we will almost always have when we're solving a system algebraically, we have a quadratic equation. And as we know, we have multiple methods of solving quadratic equations. We could graph this out, we could use the quadratic formula, we could complete the square, but I'm going to go with factoring on this one simply because factoring is, at least in my opinion, the fastest method. We need to find 2 numbers that will multiply to 20 and also add to -9. Those end up being -5 and -4, so this will factor into x minus 5 and x minus 4 equals 0. We split this off because we know that either x minus 5 equals 0 or x minus 4 equals 0, which tells us that x is 5 or x is 4. Now, what separates the system of equations from just solving a quadratic equation is, in a quadratic equation, this would be the end. Why? We were only given 1 variable in a quadratic equation. In a system of equations, we're given 2. So we need to actually find, if we link back to solving graphically, we need to find the 2 points at which these graphs crossed. Now, the points are not 5, 4, because a point is always an x-coordinate and a y-coordinate. So now that we have the x's, we need to actually go and find the corresponding y's for each one. How are we going to do that? Well, we'll take either one of the equations. I prefer to take the easier one, and the easier one is usually the line if we're given a linear equation. We have right there what we substituted in. That's going to be a good place to go. So I just have to move over to the next slide to get enough space. So when x equals 5, well, what we know is that 5x minus 10 equaled y. Substitute in that 5 for x. Do some calculations. 5 times 5 is 25, and 25 minus 10 is 15. So what this tells us then is that the point of intersection of these two graphs is at 5, 15. All we need to do to find the second point is just repeat that process with x equals 4. So we had 5x minus 10 equals y. I'm going to go straight ahead and substitute in the 4. Do the calculations. 5 times 4 is 20. 20 minus 10 is 10. And our second point of intersection is at 410.